Here is for all those people who have had any type of physics or psychology in their life. You may have once heard the term Weber's Law. Weber's Law, also known as Weber-Fechner's Law, is an important law quantifying the perception of change in a given stimulus. Okay, that's a cool definition, but what does it mean? All this law means is that the change in the stimulus that will be just noticeable is a constant ratio of the original stimulus. Now, let's rewind. Let's start from the beginning, from when the law was originally made. The law was originally made to describe researchers on weightlifting by the German psychologist Ernst Heinrich Weber in 1834, but then was applied to the measurement of sensation by Weber's own student, Gustav Theodor Fechner, who later went to develop from the law the science of psychophysics. For Fechner, this law meant that there was only a spiritual world and no physical world. However, to others, it only meant the possibility of a scientific quantitative psychology. With Weber and Fechner's work together, it had been a very useful thing, especially in hearing and in vision research. Altogether, their work has had a powerful impact on attitude scaling and other testing and theoretical developments. Enough with definitions, let's see an example. An example of Weber's law is, let's say I have a weight of 2 pounds in my hand. It took some effort to try to lift my hand up as I could feel the resistance because of the weight in my hand. What if I add 0.05 pounds to it? It's not a very noticeable change. I could barely feel that anything was added. Let's add more weight. Let's add 0.2 pounds. Now I'm holding 2.2 pounds in my hand and I notice the difference instead of when it was only 2.0 pounds. Now let's move on to a 5-pound weight. What if I add 0.2 to the 5-pound weight how I did to the 2-pound weight? I don't feel much of a difference this time. I could barely feel that anything was added. However, let's continue adding more weight. What if I add 0.5 to the 5-pound weight? Now I feel the difference. I feel more of a resistance and I could see that there was more weight being added. For the weight of 2.0 pounds, the increment threshold to feel the difference was 0.2 pounds. However, for the weight of 5.0 pounds, the increment threshold for the difference was 0.5 pounds. The ratio to this is 0.2 to 2.0 and 0.5 to 5.0, and they both equal the same thing, which is 1. All the ratio just means is that in the 2.0 pound weight, I felt a difference when 0.2 was added to the weight. But when I had the 5-pound weight, I only felt the difference when 0.5 pounds were added to it. This is Weber's law because the ratio of the increment threshold is a constant or is just in proportion. Another example is, let's say we're in a silent room. It's all quiet and you could whisper to your friend next to you or at a little distance and they will have no problem hearing you. Now let's try to do that at a rock concert. You could whisper to your friend at a rock concert next to you and they will have no idea what you are saying. You will have to be yelling at the top of your lungs for them to hear you. This is why, whether you're whispering or you're yelling, it is different in accordance with the background intensity. And when you measure the increment thresholds in the intensity backgrounds, it increases because it is in proportion to the background. All this means is that your voice will either be higher or lower according to wherever your background or wherever your setting is. Now we will see what the Weber fraction is, aka the Fechner fraction. It is I over I, which equals K. If you rearrange the equation to I equals IK, I times K, you can see that the Weber's law predicts a linear relationship between the increment threshold and the background intensity. Below is a plot of some hypothetical data showing Weber's law. The slope of the line is a Weber's fraction. Weber's law may not always be true, but in most cases it is a good way to compare performances. Now, we could clearly understand, now after this conversation, we could clearly understand what Weber's law is, where it came from, some examples, and how it is being used or when it is being used. Thank you. I hope you have learned from this and you are able to truly understand what Weber's law is and when you could use it in your life.